Hello. I thought of giving another presentation of Oracle GoldenGate concepts. So there are a few what we call so-called Oracle GoldenGate introduction and so on and so forth. But I haven't seen anything to do with Oracle GoldenGate concepts. So here goes. My name is Keegan, and let's see the first slide. All right. So many of you must have seen this diagram. It's available everywhere, most introductions, Oracle websites, and so forth. The reason why I'm showing it today is because I figured it's excellent. It actually tells the part of the story about GoldenGate. So what do we have? We have a GoldenGate process reads transactions from transaction logs and establishes the database sections to get metadata, database info, whatever that is needed to capture the transactions as ongoing. So the way GoldenGate works is that when it captures the data, it put in what we call trail files. So it is like, if you like, it is a GoldenGate redo log or transaction logs on the stuff that you ask it to capture. So there is usually a pump whereby for GoldenGate's primary use to a lot of sites is actually to move data from one server to the next. Yeah. So in which case, pushing it through IP to the cloud and to another server seems to be the most logical thing to do. So you transport it using TCP/IP link. And then on the other side, you have another GoldenGate installation, whereby what we call a GoldenGate delivery or replicate process, which reads the trail files because those are being captured, and then you can apply it to your target database. All right. So let's have a look at what, to me anyway, it's the Oracle GoldenGate's three main concepts that make GoldenGate being Golden. So the first thing is transactions. So GoldenGate does not do anything if the transaction is not complete. So in which case, if there's a begin, there's no commit, well, you're not going to see it in GoldenGate trails. Yeah. So GoldenGate will not start capturing until the transaction is committed. So the concept of transaction is important. It creates integrity. So in which case, it doesn't leave a target database, hanging with half a transaction and so forth. So in which case, everything that you get that is being replicated by a GoldenGate processes will have complete transaction integrity. The other concept about GoldenGate is tables. So in which case, how do you tell GoldenGate what to capture, what to pick? So in which case, as far as GoldenGate is concerned, you just tell which tables you want. So in which case, a particular transaction could update table A, B, C, and D. And if you ask him only to capture table A and C, that's what he does. You still wait for the transaction to commit, but you will only capture table A and C. Okay, of course, you can ask it to capture everything by saying something like myschema.asterisk. So in which case, it will capture all the tables. And the other concept that makes GoldenGate being GoldenGate is what we call GoldenGate trails. Yeah. So you can't move GoldenGate data via memory or anything like that. It has to be written physically to a disk. So in which case, it has to be written into trails. So it's a sequence of trails, very much like Oracle's archive logs, if you like. So you start with 0, and then when it's full, it goes to 1, and so on and so forth. Yep. So in which case, that's the trails. So with these three concepts, you can then see how GoldenGate is designed the way it is. All right, let's talk about transactions. So I was saying before in the previous slide, GoldenGate will only capture committed transactions. If you're halfway transaction, you will not ever see that transaction. So in which case, if GoldenGate is tracking half a transaction and you stop the process, no, you won't see it being captured. Yeah, obviously there are ways to recover, which I will discuss later. So, and then after the transaction has been captured, it's written to trails, you can apply any way you want. So in which case, if you have a source table that has 3 columns and your target table has 5 columns that make up of a variety of other columns and so on and so forth, yeah, go for it. If you have a source table that has 10 columns and your target tables are only interested in 3, cool. It will do that for you. So you can apply it any way you want. Okay, so GoldenGate tracks transaction based on which table it is asked to track. So you tell GoldenGate what you want to capture based solely on tables. So you give it a table name and you can wildcard them. So in which case you can say my schema dot a asterisk. So you will capture all tables on that schema beginning with A. Yeah. Or you can spell them out. You can say capture my schema dot table A, my schema dot table B, my schema dot table C, and so on and so forth. You can list 10,000 lines if you want to. Yeah. So in which case you can have an option of using wildcards or fully specified. So we have an example here. So how does GoldenGate capture this particular transaction? So we have a begin transaction, update table A, table B, table C, and then this commit. So in the GoldenGate or OGG is asked only to track table A as shown in the parameter. So you will see a parameter of that sort, table space table A. So in which case specifically to track only table A. Yeah. So in which case, how would you go about doing that? So there's a begin track. So in which case, every time a transaction starts, GoldenGate tracks that. All right, irrespective of whether the table is updated or not. It doesn't know. You start a transaction, well, it has to start tracking it. It doesn't know whether the table that you asked to track is going to be in this particular transaction. So it saw a table A being updated. Good. It will then record this particular table. And then it's going to ignore table B and C because of the fact that it's tasked not to do that. So when the transaction commits, only DMLs for table A are captured. All right. So let's look at GoldenGate trails. So Oracle GoldenGate capture DMLs are written to all GoldenGate trails. So in which case, GoldenGate trails is going to get all type of structure. It is written as a flat file. Yeah. So in which case, I'm quite sure Oracle doesn't. Well, it used to publish how the trails are being formatted. Not so now. There are tools to help you read them, called logdom. But for all intention purposes, that's what it does. So GoldenGate will capture DMLs according to what you tell it to. So in which case, you tell it to using table parameters, and it's actually written to GoldenGate trails. So GoldenGate trails are created and written by the extract process. So what we call the capture process. Yeah. And GoldenGate trails are then moved to the target server. So as was in the first or the beginning slides, we show that there is a extract, something called an extract pump that you can read from the local trail, and then in which case you can push it through the IP, TCP IP into the cloud, in which case it will then reach another target. The other really interesting fact that you can see about GoldenGate trails is that GoldenGate is created on any platform. So in which case, if you have a so-called Oracle database running on Linux, it's created obviously on a Unix platform, in which it could be a reading of a Oracle 12c database. Yeah, so in which case the GoldenGate trails are created there, and you can move to any platform. So in which case if your target happened to be the database happened to be a IBM DB2 sitting on an AIX system, so in which case that trail can be moved as is as a flat file across to the other platform. So in which case then you can then have the same trail. So in which case, if you want to, for example, replicate the data from Oracle to DB2, and you also want to move it to a Windows Microsoft SQL, you can move the same trails across to the Windows, and then you can be processed by Microsoft SQL. Yeah. So in which case, it is then, this is something that I coined. So in which case, I say that the trails and database unaware. It doesn't really care where it's going to. Yeah. So in which case, when you capture when you have GoldenGate extract running and you're capturing the data, you don't have to be concerned what you will end up being consumed. Should it be are you going to be worried that it's going to be kept consumed by DB2 or a Microsoft SQL or by Informix or by another Oracle 11R2 database? No, you don't really have to care. Well, there's still the little parameters that you have to tweak here and there, but basically generally, you don't really have. All right, in this slide, I intend to show you in greater detail on how GoldenGate processes interact with each other. It's still fairly high level, but it's a little bit more, um, for a better word, deep dive, okay, or whatever it is, into the GoldenGate process. Okay, without GoldenGate running, so what do we have? Usually what's happening, well, typically on the Oracle system, you have a source Oracle database, so you have something called the redo or archive logs. So in which case, if you're running something other than Oracle, the redo and archive logs are just transaction logs, yeah? So basically that's what you have. So what do you do? So what does GoldenGate do? So GoldenGate has something called, I split the screen up basically into two chunks. So on the left, you have the source Oracle database. On the right, you have a target Oracle database. All right, so you can see that we are actually capturing from the source and replicating the target. So GoldenGate has something called GGSCI, stands for GoldenGate Software Command Interface. So one of the first thing that you do in there is to start the manager process. So the manager process starts all the other processes. So the first thing that you do is that you jump into GGSCI, you start manager. After that, when you start anything else, it is the manager process that actually starts the other processes. So the capture processes, the replicate process, so on. Well, basically that's only two, but there are other little things called task and initial load processes, but we won't get into that for the moment. So the manager, usually you provide it with a port number. So in which case the default port number happens to be 7809, although you have to provide that. So that's the port number provide a way whereby a extract could actually talk to a remote server. Yeah. So in which case the port 7809 will be open, so it knows where to send stuff to. So anyway, that's the manager processes. So the next thing to do is that we configure or start the extract process. So one of the things that we start the extract process on the middle top of the screen, you can see something that I configure called extract eSource. So by the way, these are actual parameter, and those four lines parameter will work. Yeah. So in which case, then you can specify user ID because of the fact that you need to log on to a session in the source database. So you provide a user ID, provide password. Obviously, a lot of you is going to be aghast by that. The password is in the clear and so forth. There are ways to hide this. All right, but let's not get into this for the moment. So you log in the session. So the next line, you see something called extract trail. So you define where you're going to put your GoldenGate trail. Yeah. So in which case, I decided to put in on the GoldenGate directory. There's a subdirectory called the / and it has a prefix called AA. So as we know, as I was saying before, GoldenGate trails is just a sequence of the trail files. It's very much like transaction log. So you give it a prefix AA, and it starts a series of zeros at the end. So in the latest version 12C of GoldenGate, there would be AA followed by 9 zeros. Then the next trail, when the AA0 is full, it will then sequence to the next one. So it would be AA 8 zeros followed by 1, and so on and so forth. So in this case, I decided to say, okay, track all the tables, track all the transactions that touch table schema HR, beginning with TC. So in each case, that's what I specify to do. Yeah. So then on the other side, on the lower left-hand corner, you will see something that I configured called an extract pump. So what does the extract pump do? The extract pump's binary is actually the same as the extract, in which case you tell it that you want to send this group of trails that you created in the .AA across to a remote server somewhere through through the network through TCP/IP. Yeah. So you will see some parameter files, something called pass through, which basically to say, hey, look, read everything on the trail and just pass through blindly. Do not do any processing. Just push it across. And then the next line, you can see something called remote host. So my target IP name happened to be called server B. And obviously, as I was saying before, you need to specify the manager port. So which is port 7809. So on the remote trail, I say, hey, look, write on the remote server, some in the directory called .dat/AA. It's the same name, but obviously it's on the different server. Well, it's a different trails. Yeah, it's a different server. So again, I say, grab uh, all the records that have the table in it. So table hr.tc asterisk. All right. So what's going to happen? So the next thing that's going to happen is that when you start the uh, online extract, it starts capturing transactions. So you can see those little dotted red arrows. They read from the redo, it reads things from the source database, and so on and so forth, and it tracks transaction and so on. And it writes them to a trail files where the transaction is committed on the table set is specified. And then it's being read by the extract pump, and it's going to push across to the um, target server. So in a target server, that's a process called a collector. So the collector communicates with the pumps and writes the GoldenGate trails onto target. So basically, the collector and extract pump talk to each other. It moves their trails on the source side and writes on the target. Yeah. And then, in which case, the replicate will read the trails and then you write it to the target database. So what does the replicate parameter file looks like? So you give it a replicate, you give it a name, like try to call it arta. Again, you have to create a session because at the end of the day, the replicate is no more than a SQL application. Yeah, so that's what it does. So you specify user ID, GGS user, password, so on, and you say map HR asterisk to target spot.asterisk. So in which case, the tables on the source is from schema HR, the target schema is code. Yeah. So in which case, every time it reads the trails, every time it encounters some records that needs to be processed, it processes it because of the fact that I put the character asterisk, which means replicate everything. All right. So that's basically how these things flow. Okay, on this screen, I will show you basically how extract tracks transactions and write them to the trails. So when you start extract, yeah, so you start extract, you say it will start tracking transactions. Usually you give it time. So you can say begin, whatever the time is now, noon today, or begin now. So it will look up the walk-up time and it will start capturing transaction from this time on. But unless you are really, really lucky or unlucky, one way or the other, your begin time is going to point somewhere in the middle of some transaction. It's going to ignore that. Yeah, it's going to look for the first begin. So it says, hi, a transaction one starts. So it tracks it. As I was saying before, it doesn't know what it's going to capture because it doesn't know what to capture. So in which case, it doesn't know what the transaction is going to do and so forth. It will track all transactions. So if you have 1,000 in-flight transaction, extract will track all 1,000 in-flight transactions. So transaction one, right, does some DML, another DML, and then in which case transaction two starts, transaction one still going. So in which case you would track transaction two, and transactions two start having DMLs and so forth. And then transaction three starts, the other two transactions are still working away, no commits. Transaction three starts, tracks that, more DMLs for all three transactions, and then transaction three is commit. So you can say, it committed. So in which case now I can grab all the data from that transaction, and then in which case you will write on to the GoldenGate trail. Yeah, And you can also see it by extract bubble, transaction tree disappears because of the fact that it's done and it's written to the trail. And the same thing happens. DML occurs on the other transaction. Transaction 2 commits. Transaction 2 it's going to be written to the trail, and then it disappears off the tracking list for the extract because it's done its job, and so on and so forth. Transaction 1 commits, and then it's going to return to trail. So easy. That's how transact extract does its work. All right, and then it writes in the trails. Okay, so how does the replicate process those transactions? From the previous slide, you can see that on the GoldenGate trail, there are 3 transactions being written in order. Transaction 3, remember, committed first. Transaction 2 committed second. Transaction 1 committed later. So in which case there are 3 transactions. Replicate will then process the trails, and then it will say, as I was saying before, the replicate in all respect works like a SQL application. So in each case, it begin a trans. So it start a transaction. So in which case, it will process the records for transaction 3. So in which case, there's some DMLs being done. And look, it hasn't done a commit yet, although transaction 3 is a whole transaction by itself. The reason why it doesn't do that, the replicate does not commit on the commit order. It does the commit order. Whenever the source transaction commits, the replicate doesn't just commit. Yes, you can force it to, but it doesn't do that by default. The reason why it didn't do that by default is because of the fact that grouping transactions and then begin and then committing it is much, much more efficient. You can see a 40%, 50% increase in efficiency just by doing that. So the way it works is that, say, for example, there are, 50 transactions, or let's make it a little bit more. There are 500 transactions on the source side that has 2 DML each. Yeah. So in which case, if the replicate were to do whatever the source does, it will have to do, begin, commit 500 times. So which is really inefficient. Instead of doing that, it will then grab all the DMLs for all the 500 transactions, do it as one bulk transaction. Yeah. So it will then group them and commit. So the different versions of GoldenGate changes the default grouping. So I believe right now it's 1,000 DMLs before it start to engineer a commit. Previously it was 2,000. Yeah, again, you can tune that, but for all intention purposes, that's what it does. It does grouping. So it does the transaction tree, and then if that's the only thing in the trails, it will, whether or not the grouping target is being met, it will then commit. So in which case, you can see that it's actually grouped the transactions committed. So when it commit a transaction in a target database, yeah, and the replicate will then go and check the trail to see whether there's any more things to do. Right. So it's just a very short introduction of what GoldenGate is. As far as, well, it's not an introduction, sorry. It's a GoldenGate concept. So yeah, if you like this video, you can take like, you can dislike it, you can take dislike, you can put a comments in the video section, or in which case, if you have questions generally, Oracle has a wonderful forum called the community, Oracle community. So if you were to go into your favorite browser, even Bing works, you can search for Oracle GoldenGate community, and then you can post your questions there. Yeah. So in which case, I'm a pretty active member of the that particular forum. So if you post your questions there, yeah, somebody will answer, me, whatever. That's a few people that's answering those questions. All right then. Thank you very much.